Dear students, today in this video presentation just before your final term exams, we are going to review and check the groundwork in mathematics, whether it is up to date or not. It is just not simply possible to do each and every question that was done by you throughout the year before exams. So we need to amplify the focus on selected quality graded questions that are essentially important and a one-time must-do kind of questions. So at this point of time, you need to practice only the selected questions. So here is such a collection of questions that has been prepared by experienced teachers, student-teacher interaction programs, multiple doubt sessions and student feedback sessions and many other sources. So be in touch with us till the exams. Every time we will try to come up with more such videos to meet your requirement that can boost and guarantee the success in the final exams. Today in this video lecture, I'm going to tell you from my teaching experience one very good question from C.B.S.E class 10 board examination point of view. So the question is, as you all can read from the display, that there is a farmer who connects a pipe of internal diameter 25 cm from a canal into a cylindrical tank in this field, which is 12 meter in diameter and 2.5 meter deep. Now, because the farmer is collecting the water from a water resource, this is the cylindrical pipe. Water through this pipe is flowing with a speed of, it has been given to be as how much? 3.6 km per hour. And the internal radius of the cylindrical pipe through which water is flowing, literally it is having 12.5 centimeter radius. Now the water is flowing and getting collected into a huge cylindrical tank like this. I'm drawing all because your imagination can run along with the question. So if at all if it comes, you can recapitulate only because the diagram will be there in your mind, because it's very easy to memorize pictures rather than text. So your drawing adds a very good amount of value to your presentation, as well as your imagination, your recapitulation and all things helps a lot, isn't it? So the water has got collected to a height of 2.5 meter. The radius of the cylindrical tank is given to be as how much? If the 12 meter is in diameter, so it must have 6 meter radius. So the water got collected and falling into the cylindrical tank. The cylindrical tank went on collecting the water, and in this way the water got collected. Now there is a correlation between the volume over here and the volume of water which is flowing. These two volumes are always the same. Now this only you need to understand with a good amount of patience. See, I just write a formula code, V equal to SAT. This means this is the volume which got collected inside the tank, which is volume of the cylinder, and this is what speed with which water is flowing. So this is in kilometers per hour multiplied by area. I will bring this in meter square, and the time I will bring that in how much? Hours. So here the volume will be also in meter cube. So the units have to match first of all. If on the left hand side there is meter cube, on the right hand side also we need meter cube to come. So this will be meter cube equal to, this kilometer has to be converted to meters per hour into meter square into hours. So this is how the formula is working. You can see this R and R got cancelled. Meter into meter square had become meter cube. So the formula, because the dimensions are matching, so the formula also is correct. So this is how you must apply such things in order to keep in mind. So I'll continue with the calculation part. So here the volume has got to be calculated. It is pi, radius is 6 square into height is meter. I need not worry because my entire answer is coming in meter cube, because radius is also in meter, height is also in meters. Here it is kilometer per hour. I will convert that into 3.6 into 1000. So this converts that into meters per hour. Okay. And area of cross section of the pipe, this is pi into radius is how much? 12.5. So it can be 12.5 upon 100. This has converted into meter. This is in meter right now because it was 12.5 centimeter. So 12.5 centimeter, if that is divided by 100, so it converts to 12.5 by 100. Now it is in meters. So that is in meters. And the time t is already in hours. So pi and this pi got cancelled. So this is 36 into 2.5 equal to 3.6 into 1000 into 12.5 into 12.5 divided by 100 into one more 100, like this. Now the calculation will be very, very simple. It is not that tough. To students it seems, but you have to carry it with a lot of patience. Then only you can score full marks in such questions, because these questions are mostly expected in section C as well as section D. So here I will have to abolish the decimals first of all. If I abolish this one, so here I will have 110. If I abolish this decimal, here 110 will come. Abolishing this will bring 110 over here. Abolishing this will bring one more 10 over here. So let us cancel first of all the zeros on either sides. See, this 36 can very easily get cancelled with this 36. This 10 will get cancelled with this 10. Right? Now 1, 2, 3 zeros are there. 1, 2, 3 zeros got cancelled. Now what is left over? See, here it is 25. And here what we were left over with? 125 into 125 divided by 100 into 10, that is 1000 into t. Isn't it? Now here you can see, you can divide it with 25 5s are 25 40s are 5 8s are. Now here the next step, t will be equal to 8 into 25, 8 into 25, and this 125 will come over here. So the next step reduces to 25 5, that is 8 by 5 hours is the answer. This much of time would be taken if the water through this pipe flows into this tank, and if it runs for 8 upon 5 hours, it can fill the cylinder to this height, whose diameter is 12 meter, say radius 6 meter. It will fill this tank to this height only if it flows through this pipe for 8 upon 5 hours. But you need to convert this in a question from similar triangles. That says that there is an equilateral triangle. There is an equilateral triangle ABC in which there is a point marked on D which is given to be as 4 times of BD is equals to BC. Means BD has become 1/4 of the entire length BC. Okay. So we have to join AD, because in similar triangles, particularly in this case, there is hardly any chance of similarity. So it's better to move with drawing some construction, drawing a perpendicular from the vertex of the triangle on the base BC. It means that if we draw an altitude from the vertex of an equilateral triangle onto the base, that is actually 4 in 1 character. What we know, that it is an altitude, it is a perpendicular bisector, it's a median, it's an angle bisector, it is 4 in 1 character. So right now, because it is an equilateral triangle, AB is equals to AC, and also that is equals to this length too. So we have to prove 16 times of AD square is equals to, so the proof will start in this way, that it says you just begin with AD square. Now AD square, in which triangle it will be? It will be in this triangle ADO. In this triangle ADO. So in triangle ADO, how much AD square would be equals to? It will be equal to AO square plus OD square. This is by Pythagoras theorem. Now AO square could be expressed in some other way too, by applying once again Pythagoras theorem. So if I just come to triangle, referring to triangle AOB, which is a right angle triangle, so the result will come out to be as AO square would be expressed as AB square minus BO square plus OD square is as it is. Repeating the step. So right now AB square plus OD square minus OB square. So this leads to AB square plus, this is in the form of A square minus B square, so it becomes OD plus OB into one more time OD minus OB. But as we know that AB square is as good as BC square because it is the side of an equilateral triangle, so it becomes BC square plus OD plus DB. OD plus DB is how much? It is OB. It is OD plus OB. So this OB I can change it to what? Writing it as OC, because once we have drawn a perpendicular, it is a perpendicular bisector of BC. So OB is equals to OC also. So this OB changes to OC, and this once again repeats. Now here what happens? OD minus OB. OD minus OB. So OB is the bigger one, OD is the smaller one. So smaller one, when subtracted from the bigger one, what you get is minus of BD. So our result comes BC square plus OC plus OD is how much? OC plus OD is as good as CD, and that multiplied by minus BD. So the result reduces to BC square minus plus minus, so CD. Now CD is how much? If BD is 1/4 of BC as per the given condition, if BD is 1/4 of BC, so CD is how much then? 3/4 of the entire length BC. So instead of CD, I would write it as 3/4 times of BC multiplied by how much is BD? As rightly told, 1/4 of BC. So the result comes out BC square minus 3 by 16 BC square. So finally, just put the result somewhere here, that AD square is equals to BC square is common. So why not I keep it outside the bracket as a common term. So it becomes 1 minus 3 by 16. So the result becomes AD square is equals to BC square into 16 minus 3 divided by 16. So it becomes 16 AD square is equals to 13 BC square. This is the final result. Okay, dear students, thank you. The next question is from similar triangles in this video lecture. These are all the questions which my students have been asking me during the practice sessions. So just expecting the same doubt maybe for anybody else also. So that's why I've just taken this question. Quite frequently these questions are being asked again and again by students. So in this very question, it has been given that there is a right angle triangle which is right angled at A. I take this one as B and this one as C. Now there are certain medians. This one is a median and another median. Here it is. CM is another median. We know that the rule of a median is what? That it bisects the sides. So this portion is equals to this portion, and similarly this portion is also equals to this portion. So again, just looking into the case, again it seems to us that this again will be a case of Pythagoras theorem, because in Pythagoras theorem the very basic sentence that on either sides of equal side, or either sides of the equal sign, if there are summation of square terms, so generally it gets solved by Pythagoras theorem. So let's start. You just see in the proof part what they have said. What they have said, BL square plus CM square. So we will also begin BL square. Here it is BL square. So this is basically taken from triangle BLA. So applying Pythagoras theorem. So it gives me BL square is equals to AB square plus AL square. And this one will be inspired from triangle MAC. So again this will be CM square is equals to AM square plus AC square. You give this equation number 2 and give this equation number 1. You add 1 and 2. So BL square plus CM square, BL square plus CM square is equals to AB square plus AC square, keep it in one bracket, and what else? AL square plus AM square. Dear students, one more question from similar triangles, and this triangle is a very important one because I had seen this question too. It has been asked so many times in the C.B.S.E board exams, so that's why I cannot leave this question. So because I am giving you short kind of questions, not that all the questions are definitely going to come with guarantee, I cannot assure it, but this is important question, it should not be left. Okay, now in the figure, means the figure is not being given. So let's draw first of all the figure. So in this one there is a parallelogram given, and the parallelogram is ABCD, means this side is parallel to this and this one is parallel to this, and the line BM means there is a midpoint and it is joining it and extended so that AD meets it upon producing it at some point so called as E. This is the question. Now what we are told in the question that M is the midpoint of DC, means this length equal to this length, means this entire length is equals to this entire length. So let's prove first of all make sure that this triangle, whether it is congruent with this triangle or not. Can you prove it? I think the answer is yes. You all are very good students, I know. You're listening quite carefully, and I also know, but to make you alive in the session, I have to ask certain questions, isn't it? So these two triangles are congruent. Why they are congruent? Let's prove it. This angle 1 equal to angle 2 because they are vertically opposite angles. This angle 3 will be equal to angle 4, pair of alternate interior angles. So these two triangles have become congruent by angle, side angle. So I can say that triangle BCM is congruent to triangle DME by angle, side angle congruence rule. Okay. Now, if this is proved to be as congruent, so by CPCT I can claim that this length BC isn't that equal to that of this length. Why? By CBCT I can claim it. By CBCT means BC equal to DY. CBCT means corresponding parts of congruent triangles are always equal. These two triangles have become congruent, so their corresponding parts are also equal. Now because ABCD is a parallelogram, therefore BC is already equal to AD. Why? Because opposite sides of a parallelogram are always equal. So BC is already equal to AD. But BC right now has been proved to be as equal to D. So these are two things. BC equal to AD. This is by the property of parallelogram. Okay. But BC is equals to D. It has been proved above. So combining these two results, what I get? That AD is equals to D. It means that AD equal to D means D is a midpoint of A. This was to be one. Yeah, this was point E somewhere it was. In the figure it was given. Now we will move to this triangle. This one that I am shading. Can you prove these two triangles as similar to that of this triangle BEC? So let me put it on paper first. The triangle BEC is similar to triangle AE. What is this? Is not A. This is something L given. Sorry, I'm greatly sorry. This is L. So BLC is similar to that of ALE. Why? This will be why. Because this angle, suppose if I take this angle as 5 and this angle as 6. Why? 5 equal to 6 because they are alternate interior angles. Okay, these are alternate interior angles. And what else? Angle 7 equal to angle 8. 7 equal to 8. Why? Because vertically opposite angles are equal. Vertically opposite angles are equal. Therefore the two triangles have become similar by what? They are similar by angle-angle criterion of similarity. Therefore, I can claim that BC divided by AE must be equal to what? We needed to prove EL must be equal to BL divided by EL. Why? Because corresponding sides of similar triangles are proportional. Corresponding sides of similar triangles are proportional because when two triangles are similar, so their corresponding sides are also proportional. But BC upon A, BC and A were holding the ratio of how much? How much the ratio it is? BC is how much? It is 1 part and A is how much? 2 parts. It is this. It has been proved earlier. So in this way we have proved that B twice of BL equal to EL. From here actually it has come. You can say that BC is equals to means A is equals to twice of BC. This result only I have utilized it over here. So this was question number 3rd of my video lecture. Okay, students, thank you. Dear students, so one more question from similar triangles, and I quote this question as a star rated question because you need a practice. You need to have a little practice. Once you need a practice before you go into your exams, because this is one such question. If one step is being lost somewhere, then you will just go on solving it. You will be somewhere stuck up and it will just land up with wastage of time. So in this very question, there is a right angle triangle like this, which is right angled at B, and there are trisection points, namely as D and E. These are the point of trisections joined with this. Trisection means, as we all know, that they had divided the entire length BC into three equal parts. So this is a question which needs a very simple approach. Don't stuck up with heavy steps, because it's very simple question, but the sequence of steps have got to be very correctly judged. Like here you have got AE square, which is one, this. AC square is this one, and AD square is this one. Means all the three are hypotenuse. So let's build first of all three hypotenuse equations. So applying Pythagoras theorem, you will have AD square equal to AB square plus BD square. Put it as equation number 1, and this is Pythagoras theorem inspired. Again, you can move with this triangle ABE, in which you will get, by applying Pythagoras theorem, A square equal to AB square plus BE square. This is also Pythagoras theorem inspired. And then one more, AC square will be equal to, again applying Pythagoras theorem, you would get AB square plus BC square. So these are three equations. Now what you do, you subtract first and second. 1 minus 2, you will get AD square minus AE square equal to AB square minus AB square will get cancelled. So you will land up with BD square minus BE square. Now AD square minus AE square is equals to BD is what? It is 1/3 of BC. So it becomes 1/9 of BC square. BE square what? It is 2 parts, means 2/3 of BC. So it has become 4/9 times of BC square. This is what the result obtained after you have subtracted 1 and 2. Right? So this will end up with 9 times of AD square minus 9 times of AE square equal to how much? Minus 3 times of BC square. So dividing by 3 on both the sides, what I get? 3 times of AD square minus 3 times of AE square equal to minus BC square. This is my some equation number, which I can call it as number 1, 2, 3. We give it as equation number 4th. And then I will just move on to the way in which I had subtracted first and second, this time second and third. Second minus third. So AE square minus AC square equal to AB square minus AB square will cancel out each other. So I'm left over with BE square minus BC square. So again A square minus AC square equal to BE square is how much? 2/3 of BC. So it has become 4/9 BC square minus BC square is as it is BC square. No issue at all to change it, right? So this had become 4 BC square. Taking 9 as LCM, I have got this. So this entire expression has become 9A square minus 9 AC square equal to 4 minus 9 is minus 5 BC square. So this is my equation number 5. Very easily could judge what next has got to be done. Simply you can substitute the value of BC square from this equation into this equation number 4th. Substitute the values. So you will substitute the value. So just put the work over here. So how much it is? 9 times of AE square minus 9 times of AC square is equals to minus 5 times of BC square. So BC square is how much? Again it is also having here also minus sign and here also minus, so minus minus gets plus. So 5 times of how much this becomes? 3 AD square minus 3 AE square. Could not see it. Okay, right now it's okay then. So it is 9 AE square minus 9 AC square equal to 15 AD square minus 15 AE square. So this a square will move on to this side. So 15 plus 9 becomes how much? 24a square. And this ac square will move on the right hand side. So it becomes how much? 9ac square plus 15ad square. So throughout you can see that they are having 3 common factors. So I can divide the both side of the equation with 3. So what I get? 8a square equal to 3ac square plus 5ad square. So this is my final answer. This is the final answer. Okay. Thank you.